Hi guys, my name is MARSYA HUSNA. Me and my groups are going to present about butane IR spectrums. So our group's name is Bombastic Side Eye. So my group members are ZAMRAATUL NABILAH, ALIA, HANIS HANNANI, and NURIN BATRISYIA.
Assalamualaikum warahmatullahi wabarakatuh. So for today's topic, we will present about butane IR spectrum. Butane is an alkane hydrocarbon with the chemical formula C4H10. The butane infrared spectrum is characterized by several absorption bands corresponding to different functional groups and molecular vibration present in the compound. To be precise, by analyzing the intensities, shapes, and position of absorption bands that butane has absorbed from the infrared at different frequency. In the IR spectrum of butane, it is possible to identify and characterize the functional groups and molecular structure of the compound. Each functional group in the molecule absorbs radiation at a specific frequency, which allows us to identify the group present. For example, since butane has linear hydrocarbon chain, you would observe strong absorption band due to the CH stretching, normally at 2850 cm until 3000 cm -1 region, and appears of sharp peaks. Based on the peak of butane infrared spectrum, you would observe peak for CC bond, symmetric and asymmetric stretching, vibration of metal group that present in butane, and more.
As we can see here, this is the infrared spectrum for butane. As we know, butane is an alkane, so the molecular formula is easy. It is CH3, CH2, CH2 and CH3. There is no double bond or triple bond. As what we learned before, peak is represented as the area of the spectrum. It is usually where the specific point vibration will occur. The peaks of infrared are all determined by the strength of the intermolecular interaction. When the strength of the intermolecular interaction happens, it can cause the width of the peak or difference. As we can see at the graph, there is a small one, there is the smallest one, and the big one. So the difference of peak width will be used to distinguish the functional group. There is a way how to read the infrared spectrum. Firstly, we need to know the two peaks that will contain in infrared spectrum. Firstly is carbonyl stretch, with a sharp peak at 1700, and another one peak is OH stretch, which is a broad peak at 3300. As we can see here, our first peak is below than 3000. It is because alkane peak must be less than 3000. If the peak is larger than 3000, like 3002 to 3004, it means that this sample contain hydroxyl group. So butane doesn't contain hydroxyl group. So this infrared spectrum is valid to say it is a butane because it is lower than 3000. Why the peak is below 3000? Because if the peak is at 3400 to 3200, it shows that the sample has a hydroxyl group. As we know, the hydroxyl group is alcohol, so it's valid to prove that this is butane infrared spectrum because alkane doesn't contain hydroxyl group but it contains carbonyl group. As we can see here, this is the N-butane infrared spectrum, which is N-butane is the isomer for butane. So if we want to know if any two molecule that we use is identical, we can look at the 1100 to 600 peak. It's called fingerprint region. Fingerprint region must be the same if the two molecules are identical. So if we use two molecules that are this isomer of the sample, it will show the same peak at the fingerprint region. So this is the peak explanation. So the first region is the smallest one. The frequency range is 900 to 700. So the frequency is 780. The type of bond is C single bond H and bending, and the compound type is 1,2,4 tri-substituted, and the characteristic of peak is strong. For the second one, the frequency range is still the same, 900 to 700, but the frequency is 880. So the type of bond is also same, C single bond H and bending, and the compound type also the same, is 1,2,4 tri-substituted, and the characteristic of peak is also strong. Next, in the middle one, the frequency range is 1600 to 1300. So the frequency is 1450. So the type of bond is CH bending. But the compound type is alkane. So when the characteristic of peak is medium. Then next is still the same frequency range. It is between 1600 and 1300, and the frequency is 1465. So the type of bond is C single bond H and still bending, and the compound type is alkane, and the characteristic of peak is medium. And lastly, it is the biggest peak here. The frequency range is around 3000 to 2500, and the frequency is 3000 around 3000 to 2840. But this type of bond is different than others. It is C single bond H but stretching. But the compound type is still same. It is alkane, and the characteristic of peak is still the same. It is medium.
There are two types of conformers, which is anticonformers and gauge conformers. So the anticonformers is the most stable conformation for certain types of molecules. In an anticonformation, the largest groups on adjacent atoms are positioned opposite to each other, creating a maximum separation or torsional angle of 180 degrees. This arrangement minimizes steric hindrance between the groups, resulting in lower energy and increased stability. So for the gauge conformer, is another type of conformation. Commonly, the largest group are positioned next to each other, creating a torsional angle of approximately 60 degrees. This arrangement introduces steric hindrance between the groups, leading to higher energy and decreased stability compared to the anticonformer.
Okay, moving on, let's talk about vibrational modes of butane. So, as you can see from this graph of II spectrum of butane, we can see that it is not so clearly distinguished, as butane has an equal number of CH3 and also has an equal number of CH2 groups. So because of its simple and not complicated composition, butane produces an IR spectrum that is much clearer and also cleaner to observe and interpret. So the first thing we do before interpreting the IR spectrum is that we divide this part. So there is a line that is at the wave number 1500. So the part which is on the left is known as the functional group region, while the part that is on the right is known as the fingerprint region. Okay, so let's start with interpreting the functional group region. First, let's make a box that fits the whole sequence here to ease our reading for interpretation. So in this purple box, there is some pronounced peak is between the wave number 2975 to 2845 specifically. So according to the IR spectrum table, this is interpreted as the CH stretching bond. So this bond and this vibration is the most common group that is present in every organic compound IR spectrum. There's one peak that touches the wave number 2970 is called the principal peak. So let's move on to the fingerprint region. We believe there is not much to interpret within this region, but since the fingerprint region is the region that helps in identifying which compound is which, then it is a must to look into it as much as possible. So the blue box, which highlighted the region between the wave number 1470 to 1365, indicates that this is a CH, deformation bending vibration absorption. This just means that CH bond in this region has the bending vibration. We can see here there is a small double peak in this blue box. So there is no specific characteristic that can be observed in this region, as it shows the typical alkane group vibration. Uh, and so this green box between the wave numbers 750 to 720 just shows that this is the CC bond vibration absorption, which apparently appears in every IR spectrum. So that's all from me. Thank you.
In conclusion, the resulting spectra are in good agreement with the experiment and can be described using only the fundamental FASDF method. The functional group that is present in butane compound can be identified by interpretation of the IR spectra. By using the IR spectra and a correlation table from a few sources in books and journals, butane molecules are determined. However, if the OH group appears as alcohol, the peak will be prominent at a frequency of 3,400 cm to 3,200 cm, according to our interpretation of butane, which revealed that this molecule is an alkene. Thus, it is established that butane has a carbonyl group. This leads us to conclusion that due to a few variables including hybridization and the dipole-dipole moment, various bonds will vibrate at a different frequency.